Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 25 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 1356. Sort integers by the number of 1 bits. So very easy problem. You are given an integer array and you have to sort the integers in the array in ascending order by the number of ones in their binary representation, and in case of two or more integers have the same number of ones, then you have to sort them in ascending order and you have to return the array after sorting it. And these are the constants. So array dot length is from 1 to 500 only, and array of I value can be 0 up to 10 power 4. So here if you see this example number 1, so this is your array. So in 1, in 2, in 4, and in 8, these all have one bit. So how you write 8 in binary form? Like this now. How you write 4 in binary form? Like this. How you write 2 in binary form? Like this. How you write 1 in binary form? Like this. So in all this, only one bit is set. So they all have one bit. Same way 3, 5, and 6 have two bits. 7 has 3 bits, right? So here now what I need to do, 0 has 0 bits, so first 0 will come, then 1 to 4, 8 all have same number of bits, set bits, so I have to just write 1, 2, then 4, then 8. So based on this number I have to do the sorting. Then after that, these are 2 bits numbers, so we have to write 3, then we have to write 5, then we have to write 6, not like 5, 3 and 6, 3, 5, 6, and then 7 comes. So this is your output, that's it. So very easy problem, right? So here what you need to do, I will create one list, and in a list I will store arrays like this, and in these arrays I will store two numbers. One I will store the actual number, and here in this side I will store the set bits count. This is going to be my approach, like this: actual number, set bit counts, actual number, set bit counts. And once I do this, then after that I will just sort this list based on the number of set bits, and if number of set bits are same, then based on the actual number. So this is going to be my approach. So I will show you total two approaches to solve this problem. In first approach, I am going to use the built-in function. So here what you need to do, first just calculate the length of this array. So array dot length you are calculating, and then after that I told you that I have to take a list, and in this list I will just add the arrays. So here you have to write it like this, and list is equal to new array list. Done. And then after that you have to just iterate over all the elements in your array using enhanced for loop. And inside this, this is the built-in function in Java, very easy. So we have used this function many times in the bit problems. So integer dot bit count, so it will directly give you the number of set bits in the number. That's it. This is what we need to do. And here in the list I will add the array, so integer array. So here in this array I will add two values. One is the actual number a, and one is the count. That's it. So easy. And once this is done, then after that what you need to do, you have to sort this. So here you have to sort like this: collections dot sort. And what you are sorting? You are sorting list. And let's say you have two lists, two list values. One is a and one is b, two parameters a and b. Then how you do the sorting? So first just check na if their bit count is not same. So a of 1 is not equal to b of 1. So at 0 index we are storing actual value, at 1 index we are storing the bit count. So if bit count is not same, then in that case what you need to do, then you have to sort them based on the bit count. So a of 1 minus b of 1. And if bit count is same, then in that case what you need to do, then you have to sort them based on the actual value. So a of 0 minus b of 0. This we need to do. So this is the custom operator that we have created here. And in the end you have to just return the result now. So the result will be in array form. So here you have to just create new, just write new int and n. So this is your result. In this you will store. So you have to just iterate over the list now. So int I is equal to 0, I is less than list dot size, and here you have to write I plus plus, and here you have to just add the values in the result. So result of I is nothing but list dot get the first array in the list, and in that array you need the zero index, because at zero index what you have the actual values. This is what you need to return, and here just simply return this result. That's it. This is your code. Now let's run it and see if the code issue will try to fix that. So see, all the test cases has been passed. Now let's submit it. So see, our solution is accepted, right? And what is going to be the time complexity? So time complexity is going to be of n log n. Here we are iterating over all the elements in array of n time, and here we are actually doing the custom sorting. So of n log n. So basically sorting, because of sorting, the time complexity we have to return as of n log n. So that is the time complexity, right? Now here, if interviewer asks you to don't use this built-in function, don't use the built-in function in Java to count the number of set bits, then what you need to do in that case? Then in that case, what I will do here, I will just simply copy this. I will call one helper method. Let's name this helper method as count set bits. Count set bits, right? So I'm going to call this count set bits method now, and I'm not using the built-in function. No, don't use this built-in function. So here what I will do, here I will just write the code. Everything else will remain same. Now I have to write the code for this one. So here this is going to return one integer only. So here I will write private int, and this count set bits, and int let's say n. Okay, so this, here I need to write something, right? Okay, so let me just do the formatting here. So now I have to write the code, but before proceeding further, let me tell you one thing, that whatever I'm going to write in this part, actually there is one name of this thing, this algorithm. So the name of this algorithm is Brian, here Kernighan's algorithm. So this is the name of this. So Brian Kernighan's algorithm. So now let's understand what is this Brian Kernighan's algorithm to calculate the number of set bits in a number. So let's say you have 12 in decimal form. So how you write 12 in binary form? You write 12 like this, 1100. So this is nothing but your 12 in binary form. Now you want to calculate the number of set bits in this number using Brian Kernighan's algorithm. So what you need to do here, this is 12. Okay, so your number as of now is greater than 0. As of now it is greater than 0. So what you have to do here, you have to update your n value as n and with n minus 1. So if you do this 12 and 11, so 12 like this and 11 is like this, 1 0 1 1. So if you do the AND of these two numbers, then in that case what you are going to get, you are going to get 0 0 0 and 1. This is what you are going to get. So here if you see, this we are doing for very first time, and in very first time when we are doing this, so this here, this thing, it was 1 here, so now it is changed to 0 in the final. So this and this both are same, but only difference is this one. So the rightmost set bit is removed now in this 12 number. Rightmost set bit is removed now. Clear? So now what is this new number? This new number is nothing but 8. So 8 is still greater than 0. So now again you have 8, so 8 write it like this, and 7 again you have to do this same thing. So 7 you have to write it like this, 1 1 0 1 1 1 and 0. So this is how you write 7 in binary form, 4 5 6 7. Yeah, right. Now again you have to do the AND of these two, so you are going to get 0 0 0 0. So this is the second time you are doing this. Clear this part? And now your number becomes equal to 0, so you have to stop. So how many times you are doing this? One time, two times. So 2 is the number of set bits. So we are always removing the rightmost set bit if we do like this. So this is removed. Then here if you see, this is removed now in this number. So now number becomes 0. So that's it. That's it. So this is nothing but your Brian Kernighan's algorithm. So let's write the code for this one. So here int count is equal to 0, and here your while loop while your n is greater than uh, 0, and here inside this what you need to do, you have to update your n as n and with n minus 1, and here let me add the comment as well, remove last set bit. So this is what's happening here, and here you have to do count plus plus every time whenever you are doing any operation, and here you are just going to return count. That's it. So this is the only change. So if you run it, so see, all the test cases has been passed. Now let's submit this code as well. So that's it. So see, our solution is happy, right? In this case also the time complexity is going to be of and log n because of this custom sorting we are doing, and here it will almost, I think it will, in worst case scenario, it will just run for O of log n times now, O of 32, because at most 32 set bits can be there. That's it in an integer. So the time complexity is totally going to depend on this thing. So that's it. So I hope that you guys are able to understand both the approaches, and if you guys still have any doubts, then please feel free to ask in the comment section. Till then, keep coding and keep practicing. Meet you guys next video. Thank you. Bye bye.